Hey guys, this is me Rachit and welcome to yet another video. Today I want to basically have this first video in the series of coding interview preparation, wherein I will be going through a bunch of different problems on dynamic programming, linked list, trees and other things, and the main intent is basically to have a comprehensive collection which anyone can refer across hot interview topics like DP, linked list, greedy, arrays, binary trees. And this is like the first video in the series, and today we will be solving dynamic programming problems from LeetCode this time, and if I find other good problems from Codeforces, I will also inculcate that in this series. This series will be absolutely free, so feel free to watch around and subscribe if this is something which interests you. So I'll be using VS Code as the primary editor over here, which is kind of a very nice workspace, wherein we also have a terminal down the lane over here, and then we have a bunch of stuff that we can do from this. Like, we have so many extensions, and I really love VS Code, so that's what I'll be using. And down the series, I think I'll also go through a bunch of few extensions which might be relevant to you. And what else? So yeah, mostly we'll be like you will be seeing this most of the time. You will be seeing the screen, and we'll be reading problems from LeetCode. And then on the GitHub repository, I'll have all these links in the video description. You can go through all the solutions. Of course, this is empty because we are just getting started with all these things. Okay, so let's go for dynamic programming. I just go to leetcode.com, go to the problems, and then over here we select dynamic programming. We get a bunch of problems. I think I might have solved a lot. We sort by difficulty, easy first. Okay, so I haven't solved easy problems, I think. Alright, I think we have a lot of problems over here, and let's see, let's get started first and try solving a bunch of them. So I've solved actually 9 out of 144. That's what they are showing. Okay, so if you are not aware of LeetCode, it's a great website of a collection of coding interview related problems. And if you are looking forward to gain knowledge about what kind of questions are asked, and also if you are looking forward to master some particular topic, or like just practice a bunch of questions for, let's say, dynamic programming or trees, I would highly recommend LeetCode. And it's a great website. Just check that out. So the first question, let's maximum subarray. Okay, so given an array integer nums, find the continuous subarray containing at least one number which has the largest sum and return its sum. Okay, so if this is the input array, this is the largest subarray which has the maximum sum, and that's what you have to do. Alright, I'll go to C++. One of the reasons I love C++ is that it's very object oriented programming related, and it's super fast. So I really love doing problems in C++, and it's very easy to find solutions in C++ as well, and it has a great community, and most of competitive programmers that I have seen also do programming in C++. So that's how I also started, and I think the pointers and the basics of OOPS are all well covered in this language, and it's a great way to learn all these concepts. Okay, so let's solve this first problem. So in dynamic programming, I'll just make a file, max sum array subarray .cpp. Alright, so what do we have to implement is this function over here, which I will do. Okay, and then so the max subarray is receiving an input array which is nums, and we have to basically return the maximum sum subarray, right? Okay. Interesting. So the first thing that is coming to my mind is just store the size of this, then what, oh, it's nums, yeah, it's nums. Oh, I think I have to include vector. Yeah. So I'm storing the size, and then I just iterate on the numbers. And now what I'm thinking is dp of I can be nothing but the maximum sum that you can build, or the maximum sum that you can get when the subarray is ending at ith position. So of course one of the possible choices is simply include the present number that you have, and we need to declare vector in tp first of size n comma 0. Another thing is that the numbers can be huge, and an int can hold up to 10 to the power 9. So this might overflow, like the sum of subarray can be stored in long, that will be better. Okay, so what we can do is dpi is numsci, like that's the basic thing that we have. Another thing that I would like to do is just have this one based. So dp0 is nothing but 0, we don't have anything over there. Then what we can do is also so my dp is 1 based while my array is 0 based. Okay, so just pay attention to that. So right now I'm at the ith number, and one choice is to just take that as it is and don't do anything. Another choice is basically to take the next best thing. So what we can do is dpi plus 1 comma nums I plus dp of I minus 1, right? That's another thing that we can do. And this is basically if there is a subarray from I minus 1, if there is subarray ending on I minus 1, we take the maximum sum of that and simply add nums to that and see if that maximizes the present thing. That's what we are doing over here. And in any case, we can do answer equal to max answer comma dpi plus 1. We can have long answer equals 0, and then we can simply return the answer. So I think this should work. Let's first check. This is a weird error that I'm getting, guys. What is the error? Heap buffer overflow. What does that mean? Oh, over here. No, I think it's fine. Quite not sure why it's not working. So this is n plus 1. We are never exceeding that. I think it should be dpi. Yeah. So we get 6. Then if we submit this, we get wrong answer. So answer can be, oh, it can be negative. So it should be minus int underscore max. Okay, let's submit this. So now it got successful, but one thing that I want to highlight over here is that the time complexity for this is order n, because there is one for loop and we are not doing anything fancy over here. All these are order 1 operations, so the overall time complexity is order n, right? So this is right now in order n. But and the space is also order n because we are creating another array of size n. So this extra space is nothing but the space complexity, and that is also order n space. I think if you look closely, we actually, so this is I, right? So if you look closely, what we can do is we can get rid of this, and we can simply have long previous or something like that, previous max. I will say just prev max and cur max. Okay, and then what we can do is we can have this also as int underscore min. We can also have this as int underscore min. So what we can say right now is that this dpi plus 1 is nothing but cur max, and this dpi is nothing but previous max. And another thing that we can do is we can say previous max now is cur max, and this should still work because at any point of time we were simply using dpi and it was dependent on dpi minus 1. So we can simply maintain that in two variables and keep on updating them as we process further in the array. Let's go back and try to submit this. I'm not sure why this indentation gets disrupted every time we paste. Let's run the code. Okay, it's working. Let's submit this, and this still works. So now we still took order in time, but now order one space, and we were able to do that. So I think let me just add this to GitHub. Am I in the wrong directory or something? Okay, in dynamic programming. So git status, git add readme, dynamic programming, git status. Alright, git commit m. I think in the commit we can simply paste the link to the lead code. It's not a good idea actually. Let me just have this problem link in the top. Yeah, now it's better. So before committing, I need to again make changes now. Git status, git add dynamic programming star, and now we can commit. Okay, so this was max sum subarray. Git push origin master, and now if we refresh our GitHub repository, we have this dynamic programming, and if you want to see the solution, you can simply refer it here. Alright, so this is order in time, order one space. Yeah, sounds good. Okay, let's see some of the problems. Let's solve one more easy one. So this is a problem called house robber, and we are given an array. We have output 4, rob house 1, and then rob house 3. So what is it? Each house has some money, and the constraint is that adjacent houses have security systems connected. Okay, so we can't rob two adjacent houses, and we have to find out the maximum amount of money that we can rob. Alright, this looks interesting. Let's implement this. Let's create a new file, robbermax.cpp, and we are required to implement this function. I think it's better if we first copy this. And we are required to. Alright. Why is it showing me so many errors? I'm not sure. It's working fine. Why it's showing errors? Yeah, it's working fine. Okay, so rob this and we'll see the time complexity later on. As usual, I will first take what else. So guys, I hope you are able to see me as well now, and I'm just simply seeing right now that this is I'm doing this after a very long time. So yeah, as it's very much apparent that I'm very much slow as well in all these things, but the main intent still stays same. I'm just trying to help you guys. So I take the input, and then basically if we rob one, we can't rob the other one, right? So let dpi, and I will comment this, be the max profit or max robbery from the first I houses. Okay, again let's use zero based indexing. So vector in dp n plus 1 comma 0, and then what we can do is for int I. So basically I have a shortcut for that, for in. Oops, it didn't work. Yeah, so now what we can do is dp of I plus 1, since we are using one based index for dp array. So dp I plus 1 is, first we can say it's simply dpi. We can safely say that like the max robbery from first I houses will be at least the max robbery from first I minus 1 houses, right? Or what we can do is dpi plus 1 is equal to max of dpi plus 1 comma, if we rob this house, so we get the value of nums I, right? And then what we can do is we can't rob the previous one, so dpi minus 1 now. That's what we need to do. Alright, the one of the concerns over here is that when we start with I equal to 0, this will give us a segmentation fault kind of thing. And what we can do instead is have this 2 based indexing. I'm sorry about that. And what we can do is nothing but, oops. So yeah guys, this should still work, and at end we can simply print out or return dp n plus 2 and plus 1. I think this should work guys. Let's see in the lead code. I'm so happy to see this segmentation, I mean the indentation getting disrupted. Okay, so we are outputting 3, expected is 4. I think we made some mistake, and have we written 1 over here? It should be I plus 1. Yeah, it's giving 4. Let's submit this. It's successful. Again guys, this takes order and time and order and space. And again guys, as you can see over here, what we need is just 3 variables, and we can have int pp max, that's like previous max, and then cur max. All of these can initially be 0, and then what we can do is replace dpi plus 2 with, since it was not like very, like we were having these I minus 1 issues, like I is 0, I minus 1 will be negative 1, so we can't use that, so we had to use 2 based indexing, which I'm not a great fan of. So we can get rid of all these things, so that's what I'm doing right now. So this is nothing but the current max, this is your P max, and this is your PP max. So if you're taking the current number, you can't take the previous one, and before that the maximum robbery is stored in PP max. That's what we did over here. And now let's finally submit this and see if it's getting accepted. Oops. What did I make? Oh, we are returning dpn plus 1. We don't need to do that now. Cmax will be what we have to return. You can simply get rid of this as well. Let's submit this, and I am pretty sure it will get accepted. Let me make the changes here as well. Um, so now this becomes Cmax. Similarly, we have Pmax as till I minus 1, PP max is till I minus 2. Alright, this looks good, and now this is order 1 space. Let's copy the problem link. Oh, it's giving wrong answer. What's the issue? What's the issue? Can you find out? Acha. Right, the problem over here is once we do that, we need to update things. So one thing is that now PP max will become P max, and P max will become C max. And now I'm pretty much sure that it will work. Yeah, this will work. I'm definitely sure. Yeah, it worked. And now simply just update the problem link, and we are good to go. Now let's add this as well. Get status. Let me just move into dynamic programming folder. Robber max, get commit minus m, max robbery sum when not from adjacent house. Alright, this has been committed. Now let's push this. So yeah guys, I hope this was fun. And for starters, this is how it will look like. And if you have any comments or suggestions, please let me know in the comments below. And I will see you next time. And this is the format of this, and I'll be solving more and more such problems on dynamic programming. And then we will slowly move on to linked list, trees, and other things. If this is helpful, please let me know in comments. If you have suggestions regarding how we can how I can work in a better way, or have some suggestions for better video content, or any topics, or the way we can project this for the betterment of everyone, please let me know in comments that also. I'll see you next time guys. Till then, bye bye.